So, welcome to this class on Neuroscience of Human Movement. This is part 15 of our discussion on primary motor cortex, and this is the last lecture on this topic. This is also part 2 of the summary on primary motor cortex. So, we have discussed the various works in primary motor cortex. What we also discussed was lesions and brain machine interfaces in the previous classes. So, I am going to summarize that in today's class. We discussed the case of lesions, how different animals behave post lesion. So, and how much time is taken by different animals to recover from a lesion. Rodents take a few hours, we said that, and cats and dogs hours to days, and primates as in macaques days, and great apes days to weeks, and in humans this may be several weeks to several months. And as you go in this direction and in this direction, for example, the potential for recovery reduces and the time for recovery increases, and also it seems that there is a critical period during which motor training must be imparted to people who have had a lesion. A question is, what is this critical period? Is this critical period the same? These are open questions in research. People are still trying to understand what this is. This must obviously be related to the size of the lesion, to the location of the lesion, to the person's previous experiences, to the actual specific case. So, it is a very unique thing, because it turns out, as we discussed in the previous class, there is this duality between brain structure and brain function. How we perceive the world at a particular point in time is determined by your brain. But so that means if I am seeing this, if I am seeing this class of students, if I am seeing the camera, that is determined by my brain and how I perceive that. But the experiences also change my brain, not just functionally, not just notionally, actually there is a structural change within the brain. So, this leads to a situation where each brain is different, and the response of each brain to injury will also be different. This is not an excuse that we are giving, this is a fact. We will have to find solutions despite this truth. So, there must be complete acceptance of this truth, that there is going to be a requirement to deliver patient specific therapy. Then with that fact accepted, then therapy is expected to be more effective for patients. So, open question as to what kind of therapy is useful. Several questions are open. So, I hope there is going to be more questions that come at the end of this course than answers. I hope that is that's achieved. What we also saw was a pyramidal tract, and there are several descending pathways, a corticospinal pathway and the corticobulbar pathway, etc. And so, the pyramidal tract is shown in red here, right. So, just going through the internal capsule and here, and it is zoomed out here. So, this is where the decussation happens, right. So, or crossing over of about 90% of the neurons to the contralateral side, which means that there are 10% of the neurons that project either ipsilaterally or bilaterally, right. About 80 to 90% of these neurons cross over to the other side in that area. So, that is called as a pyramidal decussation, and we said that transecting this or injuries to the pyramidal tract cause typical symptoms that have come to be called collectively as pyramidal syndrome. We said that this is a misnomer. Several other problems also cause similar symptoms. We said this, we discussed this in detail in the previous classes. Okay. And we also said there are upper motor neurons or the corticomotor neurons in M1, and then there are the lower motor neurons in the spinal cord. We call this as the alpha motor neuron, and the alpha motor neuron muscle pathway is called as the final common pathway. Please find out who said this. This is the final common pathway, and some neurons, alpha motor neurons, they receive direct M1 projections or monosynaptic M1 projections. So, and there are others that receive inputs through interneurons, there are others that receive inputs through through an interneuron and to some other alpha motor neuron, etc., right, to more proximal parts of the body. And we said what lesions to these two, our upper and lower motor neurons, can do. Fundamental differences in mechanisms, right. When the lower motor neurons are injured, there is actually denervation, right. Because of this there is going to be atrophy, there is going to be flaccidity, there is going to be weakness. When the upper motor neurons are injured, the descending inputs from the M1 region are lost. The influence of this descending input is quite complicated, but at least what it does to the system is that it results in an increase of tone or hypertonia. Actually this hypertonia is preceded by a hypotonia, and an increase in the reflexes, brisk and heightened reflexes, right. We said this, brisk and heightened deep reflexes or hyperreflexia, and spasticity. So what are the classic signs of the upper motor neuronal syndrome? There are 3 classic signs. Spasticity. What is spasticity? Rate dependent rigidity. So a rigidity is felt if load is applied very fast. If the same load is applied relatively slowly, the rigidity is not felt or relatively small, right. So this is spasticity. This is different, uniquely different from the general rigidity found in other problems. Okay. What is the other sign? Classical sign, Babinski sign. What does this refer to? Babinski reflex or Babinski sign. What does this refer to? This refers to the case where the fanning of toes is observed when a blunt object is used against the foot. Suppose this is the foot, this is the hand actually, but assume that this is the foot of an adult, right, and you are using a blunt object to perturb like that, perform this movement. This in a healthy adult will cause flexion of the toes. Suppose these are toes, assume that the fingers are toes, this will cause flexion of the toes including the great toe, right. But in a person who has had upper motor neuronal lesion, this stimulus will cause fanning of toes with an extension of the great toe. This is called as Babinski sign. Such a sign is considered normal in infants but abnormal in adults. So classic sign. What is the third problem? Loss of fine movements. We said this earlier. These are the classical problems that come with upper motor neuronal lesions. In lower motor neuronal lesions you have flaccidity, denervation atrophy and hypotonia, whereas in upper motor neuronal lesions you have hypertonia, you have hyperreflexia and Babinski sign and spasticity, not flaccidity, spasticity. And in depending on the lesion there is going to be a graded response. There can be either paresis or plegia. Paresis refers to weakness, whereas plegia refers to paralysis. So this also we discussed in detail the differences between the two cases. I have just presented some points here just to remind you for this. So the attempt here is to summarize the situation, right. And then we discuss the case of brain machine interfaces, how to record from live behaving animals. Hopefully this technology will improve sufficiently enough for it to be implemented in humans. What are the challenges that lie before us, that stand between us and the actual implementation of this in humans? Many, too many actually to discuss. So that is good and bad simultaneously. It is good because it provides us an opportunity to solve this problem in a way, that is good. It is bad because well, we still do not have solution to the problem, so that is bad. Despite so much technical progress, commercially viable, a relatively affordable brain machine interface that can be used, that is scalable and sustainable, are still eluding us despite substantial progress in this field. So what are the main components of data acquisition from the brain and computation, and then that is given to a machine which is a robot arm and gripper, which is controlled, right. So this must happen, the key word is real time, like it would happen in a live human being. That means great challenges in computation, great challenges in instrumentation, right. So, the opportunity is there. So, the window of opportunity is there for all of us to contribute. How many of us are willing to take up that opportunity? $1 billion question. So, in summary, the question is, what is the scope of rehabilitation in humans? To what extent can we rehabilitate? Well, the hope is that we can rehabilitate to begin with. 2 is that what are the appropriate approaches of rehabilitation? That remains the question. One is rehab approaches or therapy, physical therapy. 2 is devices. Both of these need to improve and catch up with the problem. In the United States, 750,000 people are affected by stroke every year. In India, it is about 1.2 million people every year. So, 12 lakh individuals every year, and 750,000 individuals every year in the US. 12 lakh individuals are in India. How many of these people are going to be helped by us and by our innovations? Questions are open. There are many problems, there are many solutions. I leave you with questions than answers. Hopefully there will be some of us who will contribute to change this world. Thank you very much.